Okay, last video, we're going to determine the rate of change over an interval. So we've got our same situation. Jay's riding in a boat from his home to his friend's home. We're tracking his distance to the state line. We've got our function right here. It shows the distance of the boat in miles from the state line at any time. So the question is, what is the rate of change over the interval t2 is less than or equal to t is less than or equal to 2.5? What does it mean in terms of the situation? So we are going to use our slope formula to determine the rate of change. So we'll make that note so when we look back at this, we know what we did. We're going to use slope formula to determine the rate of change from the smallest number in that interval, so from t equals 2 to t equals 2.5. All right, so we haven't done slope formula in a bit. So just as a reminder, slope formula is y2 minus y1 over x2 minus x1. So we need ordered pairs, right? Now, we're going to find the slope over the interval from t equals 2 to t equals 2.5. That's our time. So those are x values, right? So we want to find the ordered pairs that correspond to that. So when our time is 2 hours, here's when our time is 2 hours. Let's go up to our graph and find the distance. The distance is 15 miles. So that ordered pair right there, 215, is what we'll use to find slope. And then the other ordered pair, when time is 2.5 hours, so let's go over to 2.5 hours, then go straight up to your function. It hits it right here, which is at 30 hours. So 2.5 hours is right there. So 2.5 and 30. So we've got our two ordered pairs right here. We're going to plug them into our slope formula. So y2 minus y1, we're going to take the 30 minus the 15 over x2 minus x1 here. Maybe I'll label. Here's our x1, y1 point. Here's our x2. That's hard to see. Here's our x2, y2. So I did y2 minus y1, 30 minus 15, divided by x2, 2.5, minus x1 of 2. 30 minus 15 is 15, and then 2.5 minus 2 is a 0.5. 30 divided by 0.5, I'm sorry, 15 divided by 0.5 is 30. So the rate of change over this interval is 30. All right, so what is the rate of change over the interval? We got that 30. What does it mean in terms of the situation? All right, I thought I'd type this one in for you so it was easier to read and so you could write it in your notes a little bit easier. So what does this mean in terms of the situation? The rate of change that you just found is 30, represents the speed of the boat in miles per hour. So if we notice, we got a positive rate of change. So since the rate of change is positive, Jay's distance from the border is increasing. So remember, when he's driving to his friend's house, he's getting closer, so the distance to the border is going down because he has less to travel to get there. He's getting closer and closer, so he's got less distance to travel. Once he turns around and heads back home, now his distance is increasing. It's getting bigger, bigger, bigger as time goes on. So what that means is that his distance from the border is increasing. The boat is traveling at 30 miles per hour away from the border. So this final part right here That's what it means in the context of the situation. The boat is traveling at 30 miles per hour. That's the rate over that interval. And then it's going away from the border because we got a positive rate of change over that interval.